a lot of times people start on a laptop, and then the farthest they get before they go and ask infrastructure people for help is they put it on a desktop machine underneath their desk. That's as far as they get. And then they're like, but how come I can buy this at Best Buy for $500 and you're telling me it's going to take $10,000 out of my budget to manage to support this?
Yeah.
Because the average person now has a sense on what AI could possibly do, the expectations are so much higher now.
Yeah.
Like, why does it take so long to do this thing that if I would have asked you 3 years ago, it would have taken months?
Yeah.
I expect it now immediately. Look at what's possible with generative AI now. Just because everyone with a phone in their pocket can experience it, an average person can experience it, right? Yeah. So it sets the bar a lot higher for how people have to, to how the people who are offering services to the higher layers and the app developers now, they're expected to be able to vibe code something in a weekend. What might have taken them weeks and weeks and weeks just to prototype and get to a place where they can show somebody something, the expectation now is that you could do it overnight and iterate on it quickly enough that you could have it to where it needs to be in a very short time span. And in some cases it's true. But even just pet projects that I work on, I might get it to a demo stage in a weekend, but there's so many edge cases, corner cases. Data is very messy. And I think that's like one of the challenges that we see people struggling with in the space of customers and clients that my organization deals with. A lot of times they move a lot more slowly. We have actually a couple different breeds, I would say, of client. There's some who are sort of leading edge, and a lot of times the model builders are thought to be leading edge. They are in some ways, but they also have to manage billions of dollars of infrastructure, and there aren't that many people on the planet who know how to do that. And most of them are older now. Like, it's not like the kids coming out of college are not figuring out how to go and manage a 10,000 or 100,000 GPU cluster.
It's a lot of responsibility. You can mess up really bad.
Well, and mess ups are so expensive. Yep. Like there's one of the people that we talk with they manage a large GPU based farm, and they measure everything in terms of minutes of GPU downtime, and it's always millions of minutes because they have lots of GPUs. So if they have an issue, whether it's during a training run or whether they're sort of doing pre-training processing or doing anything, if there's a hiccup, like if somebody fat-fingered a file and they deployed it and it takes everything down for 5 minutes, 10 minutes, you multiply that by the number of GPUs, and that's the number of GPU minutes. And there's a actual cost associated with that. Yeah. Right?
Very big cost. If you're talking hundreds of thousands of GPUs, you're giving me anxiety just by thinking about that.
Well, and then you multiply it by, depending on the cards you're buying, it's 30 grand a card, and you pack a bunch of those into a machine, and now all of a sudden it's like...
Oh, God. But I want to go back to something that you mentioned where it's like the expectation of me being able to vibe code something over a weekend, and then I can show that to someone. It's a little bit paralleled to what you were talking about earlier with me being able to develop something locally, and maybe it is in the predictive ML days, it's me developing a model locally, and then going and bringing it to the team and saying, let's deploy this. And the platform team is sitting there like, wait, what? And the person who developed it is like, yeah, this cost me, a few hours and a couple $100 on my laptop.
Yeah.
Why are you telling me it's about to be 10 grand if I need to deploy it?
Yeah. I think the realization, it's actually not so dissimilar from researchers who were sort of building scientific experiments and coming up with hypotheses in a small setting with a small amount of data. I think when you expand the amount of data, it's not just a matter of having to process more. It's that the amount of variety that's in that data is going to get larger and larger, and it isn't so easy to manage. And so the other one that it oftentimes surprises me is people don't think about parallelism when they start. They're not thinking about how is this going to scale in terms of the processing that I'm doing. Can I shard it across multiple instances of database, multiple instances of storage, multiple instances of GPU? Am I thinking about how much memory I have to move back and forth between machines? Because ultimately, and so our engineering team builds parallel systems, but every time it's funny, every time we get a new client, the first thing that happens is they complain about how slow it is, because if you buy something new, that's what you do. Like, I wanted it to be faster. And usually it's because what you're doing is a little different, or you're not used to how to use it or whatever. But if we find issues on our side, it's oftentimes because there's a bottleneck in either a piece of code or how we're sharding something. We thought, oh, we never thought about sharding it in this way and at this granularity, because it's hard to think in terms of parallel programming. It's hard to implement something that can scale as the programming scales. But oftentimes I don't know if it's the platform services team or the data architecture team at a lot of these research institutions, they'll take what the scientists, like part of their job, besides sort of managing infrastructure and making sure that they have services available, is to help the end user developers, scientists, researchers, whoever it is, to help them understand, okay, how do I get the most out of what I'm using?
Yeah.
Because if you run a job, if you have 10,000 GPUs at your disposal, but everything you're running ends up bottlenecking on one, then what's the point?
Yeah, why have 10,000?
So that's and I don't think you see that until you have scale. Like if I can fit it on my laptop or even on a few relatively large servers, I'm not spending my energy thinking about latency in that way. I'm thinking about either time to first token or time to something on a much smaller scale. Maybe I'm not thinking about how many thousand users I can support simultaneously. Maybe I'm not thinking about sort of how I'm routing, if you're building something with agents, how you're routing things to make sure that you're spreading your load appropriately. And then we have to start thinking about costs. Like I think a lot about model routing in terms of choosing the right cost-based model associated with, what needs to be done. And that's, because at first it's kind of an experiment, like a thought experiment. Let's think about it. Oh, let's answer the simple questions with a cheap model. And if it doesn't pass a test, or if the re-ranker says it's not good enough, let's pass it somewhere else. And so you think about that sort of hypothetically, but then when it actually starts happening, and this is where, when people deploy in, let's say, a cloud provider where they're renting by the hour, that's where you start noticing the cost escalations happen in very unpredictable ways, because now you're using these more expensive resources much more than you thought you were. So it's
like the unknown of technical debt.
Yeah.
You don't recognize it yet because you haven't even realized that you're going to hit this crossroads at some point when you get to a certain scale, that you now need to be thinking about these things, but you're so oblivious to it that you're like, yeah, okay, we're just going to do it, and you may know or have an inkling that you're bringing on technical debt. But then when you really go to deploy at scale, your platform team comes to you and says, maybe we should be sharding this.
Yeah. Technical debt's an interesting one. Like, I'd love to say that we haven't accumulated any. I can't even say that with a half straight face. I think that, what makes me excited about more development teams using AI for their day-to-day work isn't necessarily that they'll become more productive. It's that, like, the tasks that usually are really boring are ones that we could probably find a way for them not to have to do, right? I can take a senior developer, and instead of having them go and spend their time refactoring and going in and documenting their code, they can spend their time talking either to end users or to someone upstream to understand their requirements better. Because ultimately, it doesn't matter if you're building agents or you're just building like a basic application. There's never a fit at first. For the user community, there's a fit for you in your minds, right? Like, oh, this does exactly what I think it should do. But whether you're trying to sell something or whether you're trying to provide a service, the requirements gathering is such a huge part of it. And like, I try to get my team and the rest of the people on sort of tangential teams to focus more energy up front on getting as many requirements as possible.
Nice.
We have like a lot of engineers who want to go show off the thing they made. I'm like, that's great. You could show it off. But if you're going to spend 30 or 45 minutes showing something off, why don't you shave off like 20 minutes of that and just sit there and say, what would you want it to do? But get in like the actual details.
Yeah.
Don't spend time up here, because like they'll just tell you what you want to hear if you're up here. You have to get down to the level where you ask them what ifs, you think about worst case scenarios, you think about all these choices, because once you hit the go button, and if it doesn't work,
it's hard to bring it back. Yeah. You got to mom test them.
Mom test.
Have you heard that book, or have you read that book?
I've heard of it. I haven't read it. No.
You got to give all your engineers that book. That is the quintessential, like, when you're building something, you want to ask in a way that isn't giving these leading questions. Like, hey, would it be cool if we had XYZ?
Yeah.
Instead, it's like, have you ever felt any pain around doing this?
Interesting.
Okay, and there's a signal there if they say that. And then a lot of people might say, yeah, I felt that pain, but they haven't. And so you can ask questions like, so have you Googled how to fix that pain? And if they've Googled about it and they've said, you like, when you really hit a nerve is when people are like, oh, I'm in this, online forum, I'm in this community that's all about that, or I've Googled it and I found this, or whatever it may be. There's a very clear signal when somebody really has a pain around something that hasn't been solved.
Yeah, that's a good point. I probably do something similar. I just haven't thought it through in that way. I have oftentimes a skeptic or pessimist side of me that, like, I don't try to expose it in that way, but I never like it when I show something to someone and they like it.
Yeah.
I want them to say what's wrong with it.
It's so hard though, because people, like, when we're looking at it, for someone to be able to be honest to you like that, it's almost like I feel like I'm going to hurt your feelings if I tell you the truth, right?
Well, I think that's a vulnerability piece there. Like, I feel like if we ourselves become vulnerable in someone's presence, it's not like it gives them permission to become vulnerable, but it gives them the sense that they could probably also start sharing more about what they actually feel.
Yeah. This is a safe space.
Yeah.
We can let you, I could see that. I do think you inadvertently are putting a lot of pressure on someone to give you that if you show them what you built, because they know that you've put in time and hours. And so it's almost like, yeah, cool, this is great.
I get it. Yeah.
And so that I don't want to tear down what you've built. Usually the way that it manifests in me is I'll say something like, oh yeah, and could you do this or could you do that? What about if it was like this? And it's fun. I actually enjoy having conversations with people that have different personalities, because it helps me understand a bit more. Because ultimately, people who are building applications, agents, anything that's being built, ultimately it's because somebody wants it. Yeah.
And somebody is still a person so far, right? And so because of that, like, there's not one kind of person. We're not all machines.
Yeah, or I was going to say, you can just have only people giving you feedback that are Dutch. They'll give you the straight and narrow. They don't care about it. They're very direct on their feedback, and I think you'll be fine then if you can get a lot of
to know.
Dutch feedback.
I'll go to Holland and ask people what they think.
Yeah, let me give you this quick demo. But I also want to touch on the idea that you glossed over a little bit of the boring stuff and how that's really where a lot of value can be brought, because nobody likes doing the boring stuff.
I also think it's boring because it's kind of hard. I even think about in personal life, the stuff that I set aside because I say, oh, it's boring, or it's not interesting, or it doesn't solve a big enough problem for me right now. It's this kind of, you could think of it even as technical debt in some way. And I think like if you're working on a problem, or if you have a new idea and you want to create something, at least for me, I like to think about, okay, well, what do I want to make? And I'm going to focus all of my energy around what I want. I'm not going to, and if something gets in my way a little bit along the way, I'm going to just find a way to move around it and keep moving along until I get to the place that I want to go. But that doesn't really help when it's time for other people to use it or other people to interface with it, because all of those things that I went through, they're probably going to have to go through it too. And so when I think about the boring stuff, I think about, like, you start on your laptop building something and then it's time to go deploy it for real. So then your platform team has to go and think through all the things that you didn't want to think about. You didn't want to think about any of those things. I don't want to think about sharding or scaling. I don't want to think about if the server crashes. When does that happen? That happens, right? Like, especially if you come from a mindset where you've been deploying into the cloud, unless you're cheap and you're only using spot instances, and you had to think about that, right? If you were deploying somewhere where all that stuff was taken care of for you at a small scale, then when you want to go and do it for real, someone has to think through those things. What happens when a server fails? What happens when a link fails between two different locations? What happens if your user has a slow connection and you can't send back to them quickly enough? Have you thought about timeouts? Have you thought about all of those boring things that end up like killing an application and killing a user experience?
Have you done much work on like chaos engineering?
So, you're like the third person in a week who brought that up in a way.
Because it sounds very similar. Like, this idea of how can we think about the ways that it fails? Well, let's just like chaos engineer.
So yeah, there was a client that we're talking with who wants to go deploy large scale systems. And they asked me this question, if we do that regularly, and we do, but not on purpose. We have to build large systems to test, right? I don't have millions of GPUs, but I have lots of stuff that can simulate it. I don't have millions of servers, but I can have potentially hundreds or tens of thousands of servers for a period of time to go and do things with. And because hardware, because data center space, because bandwidth, because all of the things that are physical are finite, we end up having to shuffle things around a lot because one team wants to go and build an app, and we say, well, you're going to have to wait until Monday at midnight UK time, and then you have access for 4 days, then you got to give it back. And that process of turning it over and giving it back means that I'm going to call you up and say, okay, it's been 4 days. You're like, oh, I'm almost done. Oh, we're taking it. And so then we have to shuffle everything around, and then everybody's scrambling to figure out how do I make sure that, like, think about it in the terms of like checkpoint restores, right? How do I make sure everything that I'm doing is ready for that last moment notice where I wasn't planning on it?
You want to squeeze as much juice as possible out of it.
Yeah. And I think so chaos engineering, there are QA teams within our organizations who do things like that. We have some people, we wouldn't call them black box testers, but they're people who are less familiar with how our systems work that do dumb things. And that's just their job.
They are the chaos monkeys.
Right? They're like, well, how come I can't do that? Well, because you just don't do that. No one would ever do that, but I did it. Right?
What a great job.
Yeah, but then they got to file the bug reports. It's like, they got to, like, what did you do? Oh, I don't remember what I did. I gotta write it all down. Like, and the thing is, like, I'm so resistant to like documenting bugs fully. I just like to write. I clicked this button, it did this thing, I didn't like it, or it failed, or give me this stupid error. And okay, so where are the logs? What's your reproduction step? How many times did you reproduce it? I'm like, oh, come on, guys, can't you do that?
Figure that out. Yeah.
You figure that out.
It's like a perfect use of AI.
It actually is. And I think at first a lot of the development community on our side was a little resistant. And there's probably more than one reason for that. Some of them are a little bit older. And so like there was like a trust issue. Although it's funny, so I have 12 or 13 people on my team, and probably if they end up watching this, they're going to get mad at me or whatever. But because I forgot how many there were.
Yeah.
But there are some who are super forward looking in terms of using AI for as much as they possibly can all the time. And they're super eager and they're out there with it. Sometimes I have to look at them with a skeptical eye and say, maybe you're leaning a little too heavy. It's okay. Like, I'm not going to stop you, but I'm just letting you know that there is a reality that we're also trying to work on. And then there's others who are so skeptical that I ask them, I have a thing. I'm like kind of a jerk of a manager sometimes. I'm like, every time I have a one-on-one, I'm like, so show me something new you did with AI this week that you didn't think of doing last week. Nice. Right? Whatever it is. Wow. I don't even care. It could be personal. Like I took a picture of something and asked ChatGPT to figure out what it was, or whatever. It doesn't even matter what it is. Yeah. And like, I think, because I'm just trying to get people not necessarily to use it all in for everything that they do, but just to think about it outside the context of what they hear about. Just every time I have some kind of thing that I don't feel like doing, I'm like, let me just try this, right? But I do think it does take dedicated time Because if you just try stuff and it doesn't work the first time, that doesn't mean that it's bad. Like in my opinion, it means you just didn't construct what you were doing and develop your requirements well enough before you asked it to do something.
I actually gave a talk on this recently and how that is such a bad UX when we see that something doesn't work, but we have no feedback on, was it because our prompt wasn't good enough, or is it because it's actually not possible?
Yeah.
And we don't have any clarity on that.
I flew over here from Portland a couple days ago, and they decided not to have Wi-Fi on the plane. They didn't tell me until after the plane took off, so I couldn't text anybody and let them know. And sometimes I like to just zone out and not work on the plane, but sometimes I kind of need to.
Yeah.
Right. But what I thought was funny, I don't know like what your opinion on this is. If I have internet access, I see you have Slack on your screen. Slack is probably where I spend like 80% of my time now. If I don't have internet, for the first bit of time, I get a little bit nervous and frustrated. But then I spent the rest of the plane, besides I watched some silly movie or whatever, but then the rest of the time I spent just really thinking through something that like we as a team need to get done and creating a prompt to try and create a flow to do it. And if I would have had internet access when I was trying to do it, I probably would have gotten really lazy about it.
Yeah.
Right. I wouldn't have thought all the way through as much as I possibly could because I'd have instant access to like, one thing or another. And I'd say, oh, I'll just ask an LLM to tell me what I should do. Right.
100%. And actually that was one of the product things that Ben Young, who I interviewed from SourceGraph, said that they took a stance on with their coding agent was that when you hit enter, it doesn't submit it. Because he was like, we want to subtly tell people to like keep going on their prompt. And so you have to do the shift enter for it to actually get submitted.
That's interesting. Because there are often times where I'll hit the enter button, whether it's like in Cursor or whether it's even just using a chat bot. And I immediately go, oh man, maybe I should have changed what I said. But then I'm too lazy to hit the stop button sometimes. Not every time.
Yeah. I am the same way. It's like, well, let's just, maybe it works.
Maybe it's close enough.
Yeah, maybe I don't have to try that hard. That's a funny one on how much you got to work at it. But again, like, I think there's another thing with the, what did I want to say around the boring data?
Yeah.
And how, and the messy data, and how I think before we were talking about how you really can't understand until you've lived it, the messiness of data in enterprises and just big companies.
Yeah. There's whole industries built around cleaning data. But then ultimately cleaning data just puts it into a form. And some person's deciding what that form is. Yeah. And that doesn't mean that it's clean for the next person who comes along, right? And now a lot of times we're telling people, we're being trained, I guess you could say, to keep as much as possible. Because you don't know when you're gonna need it next. And there's this feeling like if you don't have it and you like, especially when I talk with organizations that aren't accustomed to being data-driven organizations, ones who are in manufacturing or ones who are in retail or even in finance, where the product that they sold wasn't data. But now that there is an increasing realization that data itself has value to it, there's this increasing desire to keep more and more of it. But it doesn't mean they know how to store it effectively. It doesn't mean they know what formats to put it in. Again, there's this expectation level that, well, if we dump it somewhere, there's going to be some magic easy way to just extract value out of it later. I don't have to think about it that much, right?
Yeah, what a disaster.
Well, yeah, but I still have this hope in the back of my mind. There's going to be this amazing thing that's going to come along. Somebody the other day, it was probably like months ago, we were talking about how a lot of organizations can only extract value out of like this very small percentage of the data that they have, right? They could have documents, they could have hundreds of millions of documents going back decades, and they're really only extracting value from like a very small percentage of it. And then, the sort of counterpoint to saying, oh, well, they need to extract more is like, look, like it's just like in his case, he was saying drilling for oil. There's oil that you can drill for that's really easy. And so until oil gets so expensive that you're going to go spend the time and energy to go after the hard stuff, you're not going to bother. And even the model builders are kind of thinking in the same way, because they think, well, you know, our techniques will get better over time. And so why bother going too deep, right? A lot of the big models basically trained on common crawl data for, well, I mean, they still do, but that was one of their primary sources of data for the first bit of time. And that's easy to get. And depending on which sort of export of it that you used, it's relatively clean. Like the news feeds are relatively clean and deduplicated and all this other stuff. And so it's easier to deal with the easy stuff first and the hard stuff later. And I think enterprise organizations, like if you think about, like when we talk about financial services companies, I'm not talking about the ones who are sort of leading edge in terms of how they're using AI or creating AI first practices. I'm thinking about the ones who've been a bank that's been around for 100 years. They have a challenge with regulation also, but extracting value out of that data it's going to be a huge effort for them. But the thing is, they have so much of it, and especially the retail banking world, they have so much about people's transactional history and their buying patterns. They have something of value. They just, you know,
it's a lot of work.
It's a lot of work, and the techniques haven't necessarily caught up to the difficulty that it takes. So I think it's about finding like a middle ground in terms of saying, you know, we want to be able to understand our clients better. We want to be able to have a data product we could sell to somebody, but let's not overhype ourselves in thinking that we could take our whatever 100 petabytes of data sitting in a cold archive somewhere and be able to offer some service on top of that. That's ridiculous.
It reminds me of the whole big data's dead movement. And I think it was the Mother Duck guys that made that big, right? Because it's like the majority of the stuff that we're using is not big data. I mean, we may have big data, but what we're actually using is very small data. And so how can we, you're building on that by saying, because small data is pretty good for what we need right now, and figuring out how to use that big data in a way that's going to be more valuable than what we're getting from the small data that's easy and quick.
Yeah.
It's a lot of squeezing for the juice.
Yeah. I think there was I went and shifted sort of companies a while ago and switched over to one of the Hadoop distributions back when Hadoop was the big, great thing, right? And I think that most of the people that I interacted with were DBAs who were trying to pad their resume with some new skill set. And there was a lot of hope. There's a lot of hope for all of this ecosystem of tools that were going to basically change the way that data warehouses operated and change the way that organizations looked at data. I wouldn't say that it didn't live up at all to its promises. I think there was a lot of transformational change that happened, but it definitely wasn't the thing that solved data problems. Yeah. And that's why I don't really see Hadoop as it was as something that organizations are continuing to want to foster. They're looking at other ways of managing data. I think that like Databricks, for example, did a really good job kind of coming in at the right time and coming up with a way to basically take the ideas behind the big data movements and then apply them in a more practical way to things that people are actually using, right? And I interacted with them a lot back when they were just a training organization. If you go back, like 10 years, they trained people on how to use Spark. And at the time I thought, how is that a business? Like I don't know if you ever went to any of their sessions, but those were probably their high level 101 sessions were like deep Scala and Java development as like the 101 intro to Spark. Yeah. And so I'm like, okay, so there's a really high bar to getting into this. And I thought, okay, I don't know how this is a business. But as they got more and more developers in the camp of Spark, they realized that we can offer, but they probably already knew this all along, but they started offering a service. And I think in a lot of ways, they developed a really good ecosystem around it. We came at things from a slightly different angle, which was we started with problems that were hard to solve for the research community. When I say research, I think about a lot of the sort of government-funded labs. I think about sort of institutions that their job is to basically process large amounts of data, either for experimentation purposes or for drug discovery or for something, right? And so they had challenges around processing large amounts of data. So we didn't start by trying to create frameworks for them. We started by sort of being the back end lower layer. And then as we start to move up the stack more and more, now we look for what the frameworks are. Like I don't want to tie myself completely to Spark because there will be transition there. I don't want to tie myself completely to SQL even, because while that might have been the way that everybody interfaces with structured data, I think that it isn't necessarily the way that people will in the future. And so like I want to make sure that the lower layers are solid enough that anything we put on top is going to be easy to do. But I also want to keep looking for what the next sort of way of looking at large scale data processing is. And my mind always goes to like, what are the parallel frameworks that are emerging, right?
Well, it goes back to that. The platform engineer is now going to have the data scientist or the researcher as their customer.
Yeah.
And they are going to come with requests and requirements continuously. And so the platform engineer is going to want to provision those requests and be able to offer them quickly to whoever their customer is. So how can you make sure that you have a plethora of different ways to offer whatever it is they need? Oh, all of a sudden it's not pandas, it's polars. Cool. We got that too.
Yeah. Yeah. And I think that, I think to me, it feels like the skill sets of all the people who are focused on infrastructure, platform engineering, data services, like it's kind of like the same analogy I made earlier, where I want to look to developers to get closer to their end users, to understand the requirements better. And the only way to do that is to make it so that the things that they used to spend most of their time on, they don't have to really spend their time on it. Like a platform engineer shouldn't have to figure out how to provision a Kubernetes cluster. It should just be like, there should just be a playbook for that. They shouldn't have to figure out how to manage the networking components in between everything, because really what they want to offer is a service. They don't want to offer metal or containers or any of that. They want to offer a service. But to offer the right service, they need to make sure that the layers that they are responsible for are either, I wouldn't say self-managed, are managed in a way that makes it so they can spend more of their time interfacing with their customer, whether that's a data scientist, whether that's a data engineer. It depends on where they sort of see themselves in that world. And it's a good time for everybody to think about, well, because I've dealt with like classic IT people for forever. And a lot of times there's the grumpy people, right? The people who they get a ticket and they just go, oh crap, this person wants something again. Now what do I have to do? But really to kind of get ourselves further in our careers or in like, what we're doing and fulfilling ourselves with, it's really more about figuring out, well, what could I do better for them so that when I get a request from them, like it's not that it's easy for me to fulfill, but I understand them well enough now. I understand what their mindset is. So it isn't like I'm on the other side of a fence. And really what I try to do whenever I meet with people who sit on one side of the fence or the other is, well, how can we get both sides a little bit closer to each other? How can I talk to the data scientists and data engineering teams and help them understand that you should think about what the infrastructure and the platform looks like, because it'll help you do your job better. And then on the platform side, you should understand why they're doing what they're doing, not just what they're asking you for, but why do they want that? Because sometimes the platform engineer says, they might be able to say, well, wait a minute, your real goal is this. You're asking me for that. I think I could probably give you something else that's going to help you to do it better, because this person's not an expert of their realm. But if you bring people closer together, they don't have to leave their worlds, but they should try to get them as close together as possible so that when they have a conversation, it's not only something that's productive, but it just gets them all sort of helping each other to get to the same place, right?
I've heard it put, and I really like the visual description of, you can look at it like there is a slide with a clear distinction of two colors, like two boxes on the slide. Or you can look at it as a gradient.
Yeah.
And the two colors are very clearly, there's a line where one color starts and one color stops, or there's a gradient of that. And I think what you're describing is, let's get to that gradient state.
I think we are in it. We just have to recognize it and say that. That's what's happening. It's just like people talk about like the spectrum, however you want to think about what that means. I don't think there is anybody who's not on a spectrum of some kinds. Like there's like, we're all there in some way or another, right? Like different parts of ourselves align with different sort of values, align with, or are sort of more, or have more propensity to behaving a certain way, to thinking a certain way. And so it's like, if we all go into it, individuals go into it realizing that, okay, you came to me with a problem. Part of me felt like that was, you being lazy when you asked for this, you asked me to provision you a database, and you asked me to provision you, a place to store data. You asked for me to provision you some GPU hours, whatever it is. There's a part of me that feels like, well, that was lazy. You didn't explain to me all the other specifics that you need. You didn't do that. But then there's another part of me that thinks, well, that's because you don't know. And if I help you know, then when you come to me, I have a much higher confidence that you thought through the things that I'm going to have to think about.
Yeah.
If people start to think about what the other person has to go through, because like, it's just like if someone makes a request, they had to sit there and write it down. It's not like they just said, oh, I want this. And like, there's a process they have to follow.
They didn't just think it and then it magically
We
appears.
would all love that. Maybe, I don't know. It sounds a little frightening, but like someone had to think through it. So it's like, okay, well that person, and the other thing is that when you're a platform services team or an infrastructure team or another team where people have to ask you for things, like, you as a platform person have to realize that if the way that you interact with your user community is negative, they don't really want to ask you for anything.
Yeah.
And so it's like, and that's why making the life better of the people in the middle, if you want to call it that, helps the people up above get what they want, not just faster, but they just get they get a better experience. And a lot of times people focus on, being able to iterate faster and, sort of being able to fail fast and to get MVPs out the door as quickly as possible. But it also is good when, if I understand holistically what you're asking me for, I can give you something that's probably more comprehensive. So you're not gonna have to come back to me and ask for another thing, right? Oh, you want a database and you want a bucket and you want a container, but you haven't really talked to me about networking. You haven't really talked to me about clustering this. You say you want a database and you said that you don't care how big it gets, but you just told me that this app is supposed to do X, Y, and Z. Probably we need to move you on to something else, right? And so that way the pain is lessened for this person because they don't have to go redo everything, and maybe they're responsible for migrating data back and forth. And the person up here feels like, I got what I wanted. Even though I didn't really realize it had to scale and stuff, and as they scale it, they don't have to make more requests, right? Yeah. So I think about things in terms, that to me is an optimization.
But what you're talking about basically is being empathetic to the other's needs.
Yeah, that's all I kind of want to go for.
But also one thing that's very clear is there's no technology involved in that, right? That's not
at first. Yeah.
It's just like a human to human type of, or potentially like culturally in the organization, hey, we go about things like this.
Yeah.
If you are so lucky to have it be a cultural piece. But I remember a lot of times in the beginning of the MLOps community, a lot where it was almost like MLOps was synonymous with solving problems with tech. But we forgot about, hey, there was this whole DevOps movement. And a lot of the DevOps movement was cultural change as much as it was like bringing tech into the game.
Yeah.
And this feels a lot like, let's remember that no matter what we're doing still, there should be this cultural or human piece to it where we're just trying to figure out and be empathetic with the other person to recognize what they're looking for. Because as you said it so eloquently, I'm an expert in one thing, you're an expert in the other thing. Let me help you, help me help you get you what you need.
Yeah. And I, because it's hard to pull this off properly. And, where I work, it's easy because everybody can talk to everybody. There's not like really walls built between the organizations. I mean, as you scale, like when I started, there was like, there were 2 people in the States and there were like 30 people in Israel. Mm-hmm. That's it. Now we're at like 11 or 1,200 people spread out everywhere. And silos have developed in their way, but they aren't because we've done it from a cultural standpoint. We've always kind of kept like a wide open, well, you could call it reporting structure. Mm-hmm. Now it's all about, well, how do we build ourselves for scale? How do we get to a place where we can be more effective? Mm-hmm. Because when you grow really fast as an organization, a lot of times you're moving quickly and you're not thinking about the technical debt that you're accumulating, not from a software standpoint, but from an organizational standpoint.
Yeah, it's like organizational debt.
It's the same. Yeah, it's the same basic thing. And but as long as there's like at the core of all the people's belief that they don't have to create walls between each other, as long as they just know that in some way. But it has to be, for a lot of people who come from other organizations where that wasn't how it is, it takes a bit of unlearning to be able to get there. Mm-hmm. And it isn't always easy. It's not like, oh, everything's great, I can just ask anybody for anything. It means that everybody's asking you stuff all the time, right?
The implications of this type of way.
But it means that everybody's also like trying to help each other all the time. And so it's for me, it's the only I can't operate at places where I have to go through all of the process, mm-hmm. right? But then when I go interface with customers who have very well-defined process, you can't break their walls down. You have to find ways where they can punch holes in it, at least to look through the other side and make sure that they can get, that they can fit this whole sort of dynamic nature of working together into a process that's still regulated and conforms to some kind of practices, right? Mm-hmm. And so and then if I talk about like what our software products do, a lot of times they're just meant to make it easier for the infrastructure and platform engineering teams. It makes it easier by making it so they don't have to manage as much at the lower layers, so they can offer more and more services up on top. We don't iterate as quickly necessarily as some of the people at your event last night. They're iterating very quickly. They'll do builds every day, or even maybe more frequently than that, right? That they're either deploying to prod or putting staging. We're more conservative in some ways because the platform can't be unstable. You have an app that impacts 10,000 users, that's a big deal. But you have a platform that impacts 10,000 apps, that's another thing, right?
Yeah. There's a big multiple on that.
And so we're trying to make it so that the people who have to manage the platform, because those are the people who sleep in data centers. Those are the people who like they live in maintenance windows. Like that's their life is like the next maintenance window. Like I spend a lot of time like traveling around and meeting with clients in different places, and it's invariable, or it always happens that we'll be out for dinner, we'll be out for something, they'll get a Sev1 page, they gotta go. They're in the car on a laptop. We're on a train on a laptop. They're doing stuff. I mean, I sometimes am in that place, right?
And last night after you did the release.
Well, it wasn't like that. I mean, mostly I try to get it to the place where like to my team, my role oftentimes is interfacing between sort of the customers, engineering, the sales organization, sometimes product management. Like I kind of go within all of these groups, but oftentimes I'm the black box tester before we release, right? QA does all their unit tests. They do the regression smoke tests. People on my team go focus on functional areas and go and try and do it the way a customer would do it. And then like usually the last week before release, I say, okay, now it's like stable enough. Let me go play with it. Let me pretend like I'm dumb and set it up for the first time. I'll go through the docs and make a comment every line. I don't know what this means. I don't like it's just like one of those things. And so like the last week has been a bit of that, because I just don't, because what ends up happening is if a client tries to use something that we've just built, the first place they're going to come is to my group to try and figure out how to make it work. So it behooves me
to know how it works.
I'm like, A, how it works, and B, how can we make the docs better? How can we make the UX
so
better?
That they don't come to you.
So they can get what they want out of it. It's just, it's the same basic phenomenon that happens between the platform and the app team. It's like, okay, when the platform team is ready to offer a service, let's say they go, oh, we finally have container as a service or whatever they offer, like when they roll that out, it behooves them to be able to make sure that they thought through what is Joe over in finance going to do with this thing, so that way when the service is there and he hits the go button on his app, that I don't get a Sev1 call on Saturday night, right? So our world is definitely in the world of people who are supporting the sort of people who are making the applications. And the best thing that we can do is make sure that they don't have to wake up at midnight, right? That they don't have to worry about it as much. That we don't have such a thing as a maintenance window to fall into. If we have to update software or do some kind of expansion of systems, that we can do so without it being disruptive to their users, because ultimately their customers who who are relying on these services, they end up complaining to this team, and that team, like they're buffering the complaints that would just come to us, right? So we do much better to make sure that they have what they need.
Yeah, I feel like I distracted you a little bit on how you travel around and you see the customers, and they're the ones that are sleeping in the data centers, and they're the ones that are getting Sev1 calls, and they're the ones that are having to do this. So how can you make their lives easier?
Well, I mean, for us, I think the way we make their lives easier is to understand their lives as well as we can. To really, and I mentioned earlier, like requirements gathering. I think that one of the things that we had done in the past, and it worked well for us at first, is we took a sample set of people who said they needed something. We built for what they said they needed. And we tried to apply it to as many people as broadly as possible. And at first, I think that works. Like we can, especially if you're solving problems that are really hard to solve, then the people who start to use it at first they're fine with some blemishes. They're fine with some, inconsistencies of like how things work. But as the number of clients, users, customers, whoever, as that scales, it's the challenge that we're at right now is like, well, how do we make sure that we're making really the right bet in a direction, right? Like if you think about like one of the metrics that we measure in terms of our success, besides revenue, everyone measures revenue, right?
That's an easy one. Yeah.
Is uptime of our systems, right? Like that's like we focus on that very very closely, and so. We're always trying to strive for 6 nines, 7 nines, whatever, right? And I think that the goal, and if you look at how those numbers are calculated, obviously, like it's not like the simplest thing in the world, but ultimately the way that we determine if we are meeting that is, did the customer ever have some kind of an outage that was related to us, right? And it's not only the platform that we look at; it's like if a customer, let's say they upgrade and the way that you do something in the new version is slightly different, right? Like the API, the APIs are the same, but maybe the behavior is slightly different because we've added some functionality or something like that. If that causes them to have an issue, that's still our issue, right? But the only way to know that is to really know what they're doing. It's not enough to know, oh, they need the API call to return a 200. Like that's not enough, right? You need to know not just the what's coming back to it, but then what are they doing with it afterwards? Who are their consumers? So when I talk to clients who are platform engineering teams, who are infrastructure engineering teams, of course I talk to them about what they say they need, right? But I always try to get a little bit further and like, who's asking you for stuff and what are they asking you for? And do you know why they're asking you for it? Because if I can know that, then it makes it much more likely that if I give you something that works, that it's not only going to work for you, it's going to work for them. And then that means that you have less reason to worry about what you're doing day to day, right? Less
reason for them to come to you and then you to go to
basically.
It's the waterfall.
I'm trying to. I mean, it's not just protectionism. A little bit of it is, right? I'm trying to protect ourselves from escalations, right? Like I would say that my role has evolved over probably 20 something years, but it's always been in some escalation kind of role, right? Like I don't know why.
So you've gotten good at trying to minimize those.
But I try to minimize them before they happen.
Exactly.
Right.
You're preemptive.
Like, and like that is a hard thing because I deal with a lot of support engineers, a lot of escalations engineers, like on our side and on the customer side, right? Everybody's an escalation engineer if you're on a call with them at midnight, right? Like that isn't like the regular app developer who's doing that. Like it's someone who's providing a service,
Exactly.
right? Like I worked at Amazon before AWS, but we were on corporate systems, right? So we'd manage like tens of thousands of servers, and everybody had pager rotation, and like even app developers had pager rotation. But from my standpoint, I only had like a certain sphere of influence that I had to worry about, but I had friends. And if they had to get on call because something failed, that was a problem for me too. So I try to like help make sure that whatever they were using wasn't going to give them a page. Right? Like
it would be a problem for you too because you couldn't finish your night, or because they would be pinging you.
Because I couldn't hang out. Like we wanted to get a beer, right? Like
I thought, and they're probably pinging you like, hey, do you know what's going on?
They might do that too. That like from that standpoint. But I even think about it in terms of like, look, when I first started working there, I was like, what, like 22, 23, something like that. Like it didn't matter as much to me, the business. What mattered to me was like I had enough money so we could go out and have fun.
And now we can't have fun.
Can't have fun with a laptop sitting in a bar. I mean, I'm not saying we didn't do that. Like, but like usually fixing sub ones with a beer next to you isn't the best practice.
Not a fun Friday night. I wanted to hit on the gigantic GPU clusters and how rolling updates happen.
Well, I can tell you our experience.
Yeah.
And I'm not going to name names because they're like some of them would let me name names, but I don't like to call people out that way, right? So some of the data centers being built now are being built very quickly, and power is not always so reliable. In fact, it's the opposite of reliable, right? I think that it's too easy to think well, I don't know how closely you follow these things, like how many gigawatts are getting deployed in Texas or in Norway or like all like the Stargate projects or any like, and the reason I pay attention to it in part is because it affects me personally, but it's also just because it's like an excruciatingly large amount of capital being spent very quickly. Yeah. And I'm like one of the data centers that we worked with a larger model builder on, they built in like 120 days, and there was a building, but they had to fit it out with all the normal things you put in a data center. And it was a gigantic data center. I don't know, hundreds of megawatts, right? Hundreds of thousands of GPUs. Yeah. And they want to make it, I don't know, 5 times as big or whatever crazy thing, right?
Of course.
But when people are running fast in that world, the effects of something going wrong are magnified immensely. And so power has been like one of the biggest challenges, and where we've been very successful is that unlike other platforms that offer the data services we provide, we don't worry so much about what happens when the entire data center goes dark. We don't worry that we've lost any data in the process because of how we've created an architecture to deal with that. And so I think,
why is that? I'm not sure I fully understand.
So basically, like, okay, let's say you're let's just talk about basic stuff. Let's say you're a client and you copy a file to a file server. That goes over the network. The file server receives it. It parks it somewhere. For performance, it usually doesn't park it straight on the media that it's going to go to, because that takes too long. So maybe it puts it into a buffer. Maybe it puts it into a card that has some battery back in case there's like some kind of a power outage. A lot of times, most file systems, let's say, would use a journal of some kind. Journals, unfortunately, have to be replayed, which means when you turn everything back on, you don't get to do anything while the replay happens. If there's any inconsistency found in any part of the metadata structures when you're mounting the systems, then you have to not only replay the journals, you have to do a file system check. And the only safe way to do that file system check is when nobody's writing to it. So now you're just waiting.
Everything's offline.
And that could be hours on big systems. Hours times all the GPUs, millions and millions of GPU minutes. God. Someone's getting fired. That's all that means, right? And like,
or a team.
Yeah. Well, hopefully not, because then what are they going to do the next day? I don't know. But so from our standpoint, we've always looked at it like it's kind of like when we were talking earlier about the person who's like developing on their laptop and they're like, nothing's ever going to like, what do you mean fail? Why do I have to think about failure? Why is that thing? But we had to, because at first, the places that we went into, if I think about like the DOE labs or NASA or NIH or any of these big HPC-based research organizations, they're used to dealing with scalable file systems that have just big problems, right? Like if there's a massive power outage, they know there's going to be some kind of like day-long waiting for stuff to be okay again, which, it's not like it was good when they had 10,000 compute nodes that needed to access data, but it's much worse now when the GPUs cost that much more. And so, and especially there's this whole race. Everyone's trying to race to build the next model to get one step ahead. It's dizzying. And so because we're always in that race, or they're always in that race, and we're kind of there with them, it's very important that if there is some kind of unpredictable thing that happens, that we can recover from it very quickly. So like one of the data centers that we were working on, they would have power outages randomly almost every day. We're not the whole data center would go, a whole data hall would go. People usually split things up into data halls where they'll have like 10,000 GPUs over there and 10,000 over there and 10,000 over there. And there's different power feeds coming into all of them. You lose one of them, it sucks, right? But it's not the end of the world. Like you still have most of your capacity and most of your GPUs still online running. And so like, but when you bring that one back up, you don't want to wait that long for your GPUs to be able to do something with it, right? And so, we of course don't like it when the power goes out all the time. We get tons of alarms. We get all the support engineers trying to figure out what's going on. But we've gotten used to it now because we've seen this is becoming more of a regularity. Because again, like a lot of times when these places are built out, they're not necessarily building them out with full redundancy for everything because all the money's going to GPUs. Like none of these people want to spend the extra money on the other stuff because they want to buy that extra little slice of GPUs to get them to a usable state. And so sometimes they cut corners in those ways. And so we provide a platform that can deal with that kind of issue. The other part of it is that when we started out, like it's funny, I was at like a user conference last year and one of our customers from NYU had told me that basically they were used to their systems. If they had some kind of upgrade they wanted to do, like a software upgrade to get new features or to fix some bug or whatever, they would have to take downtime for their systems to do it. And I never heard of that. Nowhere I worked before had ever had a problem just doing software updates in a non-disruptive fashion. And so it was a very foreign concept to me. But then I talked to all my colleagues who used to work at other places. They're like, oh yeah, we would take outages when we do upgrades. We'd tell the customer to plan for, an hour to 2 hours to 10 hours worth of downtime just to do a software upgrade. So they never wanted to upgrade. And I'm like, but if they never upgrade, how do they get the bug fixed? How do they get this thing? Like, to me, it's a foreign concept, but it isn't for a lot of people who've been dealing with the low-level infrastructure for a long time. And so being able to offer new features and services to people without requiring that they have to take some level of downtime or lose like a large percentage of their performance for a period of time is a big deal, right?
It's huge.
And like again, like we created an architecture that kind of disaggregates the state layer and the logic layer to make sure that when we're making software updates in the logic layer, we don't necessarily have to do anything at the state side of things and do so in a rolling fashion. So there's always a large percentage of performance available and the entire system is available during any of those things. So it doesn't matter if an upgrade happens in the middle of the day. We don't have to take a maintenance window to do it. You can do it anytime. And so we try to, we've created that reality for the high performance compute and now the large scale AI sort of community. And we try to bring it to more and more people because it feels like it was a hard problem for us to solve at first, but we had the benefit of spending a lot of time up front thinking about the way that other systems and platforms have been built. And we didn't actually implement any of our code for a long enough time. When our original CEO and founder and our first developer, actually Alone, who spoke last night, he was the first code writing developer at Vast.
Nice.
When he first started, they spent a solid, I don't know how long, if it was a whole year or some percentage of a year, just writing down what they needed the architecture to be, like just thinking through the architecture before they wrote any code. Then they wrote code for 1+ years before we deployed anything to any even alpha customers, because they just wanted to get everything, the foundational layer as solid as possible before anybody was going to rely on it. And so we were, because of that, it's actually easier for us to do new features. It's easier for us to build new things because the foundation's solid enough that we don't have to go and refactor anything down here anymore. Like we can all do it up at the higher layers.
Dude, so the thing that sticks out to me the most on this is that as if GPUs weren't unreliable enough.
Oh, on their own, yeah.
Now you're talking about how unreliable the power is.
Well, I mean, like if you want to deploy 100,000 GPUs, you need at least 100 megawatts worth of power to do it. Where are you going to get that from?
Yeah,
it doesn't exist. That's why you see all these gas turbines being rented or bought. That's why you see micronuclear coming up. These aren't reliable, proven ways of doing power. How many electrical engineers out there? Like I say, like, you know how like during COVID, like the traveling nurse thing was like it was a thing. That was a profession. They could make good income doing it. Now traveling electricians, they go relocate to some crappy place for like 3 to 6 months.
A gigantic data center. Yeah.
And then they end up, basically working around the clock and making a ton of money or whatever. But the thing is that they're not doing things necessarily according to the standard practice. They're trying to find the fastest way to get the most power online as quickly as possible. Then when the data and that's why it's kind of interesting. So we sponsor and attend like a large supercomputing conference every year. It's called Supercompute. Really original. Yeah. But it's mostly historically been sort of what I would consider to be classical old school HPC administrator and infrastructure managers, right? Like people who had to build out HPC systems, people who understand everything down to the cables being used between all of the racks of servers. And that isn't a skill set that's being cultivated for new college grads. That isn't but the irony is that all of the big large scale AI projects require that skill.
Yeah.
And so there's a smaller and smaller number of them because most of them are getting older. They're in their 50s or more because like a lot of the HPC environments are, classically lower paying jobs with the DOE or other places. And
it's so wild. I mean, is it because it's hardware too? That
part of it's hardware. No, hardware isn't that interesting to most people, right?
Yeah.
Unless you like want to build some cool gaming rig or do whatever and have little neon lights on it. Or
nobody wants to be plugging in. Is it this port to that port?
No one wants to think about that. They don't want to think about polarity of optics. They don't want to think about like what the signal rate is on a transceiver and whether it's compatible. Like, NVIDIA is great about releasing, new cards every year that people have to figure out, okay, now how much power do I need in a rack, right? Like it used to be like 10 kilowatts in a rack was enough, then 20 was enough. Now like 100 kilowatts in a rack is like pretty normal. 250 is now what we're seeing at some of the places. Yeah. And a lot of people won't understand what that means, but it hasn't escalated gradually.
Oh, it's just jacked straight up.
And it's like, and then you think like, how do you get that much into a rack full of servers? And then you have to think about the cost of what one of those racks are, right? You could have easily multi-million-dollar racks of servers that take up like this chair width of floor space, right?
And it's just sucking energy,
processing data, doing all of these things. And then now you got people who are managing like hundreds of those or thousands of those in a single building. And it's
going offline intermittently.
It can, right? And they do their best to make sure that it doesn't, but they need to have a platform that's reliable enough that if something goes wrong, it's not like starting over, right?
Yeah. And so I didn't quite catch, is the whole thing there with what you're doing, the value prop is that it's not just starting over?
So basically, look at it like this. Let's say you're in the middle of a training job. Hopefully you're checkpointing. That's like a thing, right?
Yeah. My buddy Todd was telling me, again, not to derail this one, but he was like, checkpointing is a fascinating art because you don't necessarily know, should I be checkpointing every second?
Yeah.
Should I checkpoint every day? Should I
it's a cost analysis, honestly. You have to sit there and do a cost analysis. But basically, you do a checkpoint where you're dumping GPU memory and state, and it takes some time. Nowadays, most people are doing what's called asynchronous checkpointing, so it doesn't necessarily impede the job. But when you checkpoint, you're basically saying, I want to take a little bit of a performance hit and time hit on my overall job to make sure that if everything goes to crap, and everything going to crap could be like a few GPUs failing, right? The wrong GPUs failing the wrong time, and then there's like a certain amount of restart that has to happen. Let's imagine the whole data center went out, right? And let's say you're checkpointing once an hour or whatever. That means you probably have to go back an hour. But what happens when the system that holds your checkpoints isn't online for another couple hours? Now you're screwed. Yeah. And then once it does come online, you still have to read back the checkpoints. And that takes time. Yeah. So it all ends up coming down to time. And I think that, like, in the way that people have dealt with this in the past when they had less reliable systems is they would say, okay, well, a percentage of our GPUs are going to write to this for checkpoints, a percentage are going to write to that. That way I don't lose everything. Yeah. They come up with all these different complicated
checkpoints.
Yeah. They come up with more complex strategies because they can't rely on the single platform. They have to split it up into pieces. But when you split things up into pieces, then you have to orchestrate your jobs around having all of these different pieces. You have to manage, like it becomes much more difficult to operationalize. Everybody wants one place. They don't like, it's like even when you're thinking about in personal life, you don't want to have 10 different places you have to look for something every time you want to look for it, right?
Could be in one of these 10 places. Yeah,
it's much easier if you know where everything is going to be, and you don't have to think about it in the wrong terms. And it also you have to think about it in terms of scale too, because as you were mentioning earlier, your friend in the FinOps world, they don't even necessarily know what their forecasts are going to look like. Well, having platforms that can scale in different dimensions. Sometimes you need more performance in one sense, and sometimes you need more capacity in another sense. If you're fixed in how you can scale, that becomes challenging. Like that was one challenge that people often had with Hadoop, was they would have jobs that would run slowly, but because of the architecture, they had to also add significantly more expensive storage along with it, because everything was tightly coupled. Right? Every node had some amount of storage and compute in it. And the only way to get performance is to shard across all the nodes very evenly. And so if you needed to add more performance, you had to add more capacity and reshard. And like, there's all these issues and layers. And so we, again, looked at that and said, that's not the way to do it. That's why we separated what we call logic from state and disaggregated things so that you could scale the performance layer without having to scale the data layer. You could scale the data layer and not have to pay the cost of scaling the performance layer if your needs changed. So part of building out a platform that's going to meet unpredictable needs is having the ability to scale in multiple dimensions without having to go tell your user community they have to go point somewhere else now, right?
But are you also thinking about it as far as like, we've got the GPUs, but what if folks want to use the AMD GPUs or the TPUs and all
so
of
we're
that?
We're not so picky, right? And I think that I'm not going to say we're not playing any favorites. Like obviously NVIDIA they're big. We like them.
Yeah.
They honestly, and they actually have taken quite a large proportion of not just GPU estate, right? They bought a company called MLOps, which is the high-speed networking interface that most of the GPU farms are using. There's other vendors in that space, but if you're buying the GPU, if you're buying the GPUs from them, then they can toss in the networking along with it. Or what they would do is build out a reference architecture that says use these networking switches, use these networking cables, all this other stuff. And then if I'm basically a cloud service provider that's trying to build a GPU cloud so I can rent out GPUs to a customer, if I buy the GPUs from NVIDIA, I'm going to get much better support from them if I'm also buying other parts of the stack from them. And so in that way, like they control a lot more estate within the data center. And they're influencing the decisions of a lot of these people who are building out these scalable systems. And then so there's that side of it. But in terms of if a client wants to use other GPUs, I mean, whether even Intel makes GPUs, right? We haven't seen them as much in terms of popularity, but we're not, we kind of try and take a more agnostic approach to looking at it. I would say that like for a lot of inference use cases, I don't necessarily know how important it will be to have certain GPUs in the future. I think for training, NVIDIA definitely has a leading edge in terms of basically creating CUDA and creating the world that people live in when they're trying to come up with how to do training. But in terms of inference, I think that They have projects, right? They have a project called Dynamo, which is basically their sort of inference focused suite of software stacks. But I think there's a little bit more flexibility in the inference space. And, I'm looking forward to when we because from our standpoint, we see people doing a lot of training and we see some inference. I think that the transition point,
shifting, huh?
It is shifting. Yeah. And we don't know what the power draw, what the workloads, what those look like as much as we do for training.
Yeah.
They're probably much less predictable.
Yeah.
They probably scale in different ways, and it'll be interesting to see.
Yeah, it's funny. I remember reading a Facebook engineering post back in the day talking about how the traditional predictive ML stuff that they were doing was lots of bursts. It was like short, fast bursts. And now this generative AI stuff is really long, intense, heavy training. And so the workloads were very different. And if you think about the inference, it's more on that like bursty side, it feels like to me, than especially it's not like a 40-day training job.
Yeah. I think what the challenge is for people who are offering GPUs as a service, or the people who are buying GPUs and trying to maximize their utilization, the challenge is figuring out how to keep them as busy as possible, but not take the risk, because the other thing is that we talk to clients a lot about GPU failure rates because they're not negligible, right? And I think that, especially because of how hard things are getting pushed, like you see failures happen much more frequently. I think people who are building systems on top of that, whether they're agentic or not, I think thinking about failure before you go build a whole application stack is probably a good practice.
Yeah.
Right? Things are gonna fail. And I gave a talk in London, maybe it was 2 years ago now. And it was like an AI-centric conference that I was at. And I asked everybody there's probably 200 people there. I asked everybody if they knew what an NVIDIA DGX was, which is a GPU server. Yeah. Nobody knew. Zero. Like most people knew what a GPU was.
But the specific number or the specific
they didn't know what a DGX was. They kind of knew what a GPU was. The thing is that most people were, at least at that conference, they were consuming based on having a service available to them.
Yeah.
They didn't think about infrastructure, which is good. I'm glad that they get to live in that world.
Right? Yeah.
They live in the world where they don't have to think about those pieces. But now that we're at a place where the scale is much larger, like those are the pieces that cost all the money. It's not like, and that's unfortunately the way that this world operates, right? So we have to make sure that we're using this very sort of expensive resource the best we can, and knowing ahead of time that you're going to deal with failures because infrastructure will fail. Yes, of course, software is going to have bugs too, right? But in the world of a developer, there's no bugs. There's no bugs, right? But even hardware.
Where is this magical fantasy land you speak of?
I don't know. I think it's there somewhere. One of the architects said, "Well, if I don't write any codes, there's no bugs." I'm like, "Yeah, but I need you to write the code." He's like, "Well, stop complaining about the bugs." I'm like, "I don't know what to do."
Dude, I like this guy already.
I'll bring him by. He's fun.
It's making sense.
Yeah.
But anyway, yeah. Going back to this idea of like the magical fantasy land of no bugs.
Yeah.
Infrastructure is going to fail.
It's still going to have problems. And even if you don't have bugs, you didn't necessarily think about what it's like to have variable levels of latency between different things, especially now that, you can't fit enough GPUs into one place to train some of these models now. I mean, they'll build gigawatt level data centers, but that takes time. So in the meantime, while they're in the race to make the next model, or they're in the race to build the next application, they have to find ways of using stuff across multiple geo-distributed places, whether that be within a major cloud service provider or in a data center they're renting or whatever they're doing. They need to be more flexible. Developers need to be more flexible. Application architects need to be more flexible in thinking about how do I make sure that when I'm running, even if it's not training, if it's any kind of application, that it can tolerate what happens when I need to request data that's somewhere else. And so one of the things that we've also done is try to find a way. I can't defeat the speed of light. Like, it's just not possible. But we can cheat a little bit, right? We can get more predictive in how we prefetch data that's going to be loaded in for an application or job. We can allow the scheduler to give us hints so that we know what data it's going to need, so we can move it from physical place to physical place in a way that's asynchronous, and that by the time the job needs it or the application needs it, it's already there, right? Like, we spent a lot of energy coming up with a way for people to create like a global mesh so the platform can extend beyond four walls of a data center into a place where you could have some stuff that's deployed in cloud service provider A and in a data center and cloud service provider B in multiple geographical places, and it will still function. And you can start to help them see the right way to interface with it so that the application is not, I wouldn't say able to tolerate it, but takes advantage of it, right?
Like when you use Instagram and you upload a photo and it's already uploading as you're writing the caption.
Yeah. I think ultimately it's funny. I interviewed for a job like forever ago, 25 years ago, maybe now. And my buddy, because it was his dad who's going to give me the job, he's like trying to get me prepared for the interview. And he's like, he said to me, he's like, what's the most important part of a network? And I was, or no, what's the most important part of like a computing environment or a computing network or whatever? And I was like, well, it's the switches and the this and the, you know, whatever I was trying to think of. He's like, no. I'm like, well, what is it? He's like, it's the user. That's the most important part. Like, and so when you think about like whether it's app design for a phone, whether it's app design for a large scale sort of enterprise app, like none of it matters if the user doesn't get what they're asking for. And I think we, regardless of whether we're at the lowest layers or closer to the top where they're interfacing directly with the user, have to remember that. Because ultimately that's success or not success, right? Like that, it, like you could say, yeah, we gave you 7 nines of uptime and the performance is the fastest that you can get anywhere. And it's like, yeah, but the user couldn't get what they wanted.
Yeah.
And so then they complained, right? Like that's ultimately what it comes down to.
Yeah. Oh man, and that is for anything. It's not just for software. Just when you're interfacing with folks or you're working with folks, you want to make sure that they understand the value that you're bringing. And if they don't understand that as the user,
then there isn't any value.
Exactly.
So then you haven't accomplished your goal.
Exactly.
And I think even if whether I'm plugging in cables in a data center or whether I'm designing an application to transform data from one format to another, like no matter what I'm doing, like there is always like someone on the other side of it somewhere. Yeah. And really, like that's like whether it trickles down to me or not, like if I think about that when I'm doing something, if I think about that when I'm educating someone on my team or one of our engineering teams to build something, if I think about that and I make sure they're thinking about that, then there's a much better chance for it to actually be successful, right? Like if you get a product requirement doc and you look at it and you're like, okay, I'll check this box and that box and that box and that box.
Done.
If they're not thinking about the mission of the user, then it doesn't really accomplish the goal, even if they check all the boxes.
Yeah.
Right.
Yeah.
And so I don't know. Like to me, it feels like most of my time is spent interfacing with clients and trying to figure out what they actually want, and then sometimes trying to figure out what they want that they're not asking for. Because oftentimes when people say, yeah, my leg hurts, like, well, maybe you should stop hitting it with a hammer all day long. I don't know.
What they're not asking for is for you to take that hammer away from them, huh? That makes sense. Oh, that's classic. Is there anything else that you want to hit on?
Well, I'm curious in terms of your thoughts. Like, you know, you started basically you have a community here in the city. Yeah. Well, I mean, that's the event that I attended, was here in the city. Like what's interesting for you? Like what's new for you that you're actually excited about?
There's so many levels to that, right? And I think I mentioned before, we started this conversation with the full stack AI and all the different ways and areas that I'm seeing people interact with AI now, because obviously it's on everyone's agenda, it's on everyone's roadmap, and everybody's thinking about it or doing stuff in it. And I would say some of the coolest stuff that I've seen recently, and this is high recency bias.
Yeah, like yesterday.
Yeah.
This morning.
Exactly. I really like what my friends Soham and Neil are doing with like prompt optimization and prompt compression in that regard, because what they're telling me is like, yeah, you got these agents, they go out and they do stuff on the internet, they come back and they've scraped a web page. 90% of that data that they come back with is absolutely useless, but it all just by default gets thrown into the context window. And then the LLM call has to figure out, was this useful or was it not?
And you're paying for that.
And that's their whole thing. Yeah, they're like, hey, you want to save some money?
Yeah,
check this out. Here's what we created. And so I think that's a cool one to look at. I think there's also, I like this. Give me a second.
When you say prompt compression, like I'm just trying to think of what that means. Go ahead.
What I understand from it, from the 10 minutes that I've spent with it is there's a lot that you can do. You can take out words or you can take out whole sentences in a prompt that are not really that informative or they're not very effective. Like you can take that out, take out tokens. Let's just call them tokens because that's what they are. So you can take out a lot of tokens and still get the same result.
Yeah. No, that's good to think about.
But they're doing it with like another model is
of course
stripping out the tokens.
A cheaper model, hopefully.
Exactly. A very cheap model. And actually, on the cheap one that you were talking about earlier, when you're thinking about how you get surprised with cloud bills, because you're thinking, we'll just have this policy where we try to answer the question with a cheap model, and if it doesn't, then it goes to a bigger model and a bigger model and a bigger model until it gets answered, right?
Yeah.
And it reminds me of back when ChatGPT came out, I interviewed this guy who created, he was a researcher at Stanford, I think, and he created Frugal GPT. And it was basically a way to try and concatenate prompts, or if you have the same prompt, you can ask it in a different way and get the same answer so that it's much cheaper. One of the strategies that they introduced in that paper was, hey, let's try with an open source model first. Like, let's create a router and maybe like a classifier model that will say, oh yeah, this can go to a cheap open source model instance, or, oh, this is a little more complex. Let's send it to the bigger model because we don't think it can get answered. And now is when I'm seeing that idea really getting put into practice. Like that's kind of mainstream in quotation marks, because we're still super niche on this, right? But people are thinking about that idea much more than when it first came out. And so I like seeing that.
Yeah.
I like seeing, I mean, all the GPU stuff. That's why I love nerding out with you about it, because I feel very new in that area. But I do recognize that, like you're saying, there's a lot of folks who have been working on hardware and building data centers, and their job is the most important thing ever right now. And there's not a lot of new graduates that are going into that area.
Not as much. It's like my son, he went to school for welding, and because he probably saw too many late nights of me being in front of a computer really like freaking out. He's like, that's not my game. I'm not going that route. So he went
with my hands.
Yeah, no, and it's much more well suited for his personality and what he wants to do. But it's a very hot commodity world to be a welder or someone in the trades now, because it isn't what people are going to school for. It's not looked upon in the same way that it used to be in terms of it being like a career. But you know, there's a world of supply and demand. Like, they don't have robots doing all that stuff right now. It's going to take a long period of time. It's just like the drilling for oil thing. It's going to be too expensive to automate most of that stuff for a long time. And so, like, I think there might be a, you know, sort of a resurgence of people kind of looking into that world. Yeah. I don't know that there's going to be a resurgence of people going in to be infrastructure engineers and people who are doing those. So we have to get smarter about making it easier for everybody to do it.
Yeah. Yeah. Or just pay them a boatload, and then there will be a resurgence.
Yeah. There are, I will say that the well-funded model builders are definitely paying pretty well when it comes to hiring people who are used to managing large fleets of servers. But that isn't like a never ending road, right?
Yeah.
It's not.
You can't count on that.
Yeah.
Especially if you're just going into it right now. It's like, is it going to still be like that?
Is that really going to be a thing? And it still isn't interesting to a lot of people.
Yeah.
Right.
Also,
I think there's like a breed of mind, I would guess you could say, where you want to fix problems that nobody else wants to fix. Right. And that isn't like that. Like a lot of people want to think that they're going to come up with some new idea that's going to solve like all these amazing problems, but they usually think about it in the higher level of, we'll call it the stack.
Yeah.
They don't usually think about it down here.
Yeah.
Right.
Yeah. Plugging in again.
Yeah.
The whole act of plugging things in isn't as satisfying sometimes. But actually, you know what I was going to say that I'm really stoked about these days, or that I've been thinking about these days really quite a bit, because I had to write a talk. And so originally the talk was going to be on what have we seen in the community over the past year and how have things developed? What are the kind of questions that are being asked? That kind of thing, like a trends type of talk. And then as I was doing it, I was like, wait a minute, there's this thing that kind of bugs me that is a lot more close to my heart.
Yeah.
And that's this idea of the UX of agents. And I kind of proposed this idea in the talk that everybody wants to be an agent and nobody wants to be a tool.
Yeah.
And so that is creating this horrible user experience for us, because we have to go and interface with many different agents.
Yeah.
And it's just like a little better software 2.0.
Yeah.
It's like, okay, I'm going to go to your website and then I have some chatbot that is an agent in the background. Cool. That's a horrible experience for me.
People, I mean, I think it's like this idea that an agent would offer more value than a tool in terms of differentiating from something.
Well, and you don't want to give up that relationship with your customer.
Yeah.
Because now if you're just a tool, like who is the gateway to the internet?
Yeah.
Because they're going to be the ones that capture all the value, right? And now you're going to have to figure out, how can I get my tool, which is really my product, to be consumed by your agent? And that's where I think there's this huge tension that's happening. And so for us as consumers, the better user experience, I argue, is that we interface with one agent that can go off and do anything on the internet.
Yeah.
Because I don't want to have to go and find the place.
Yeah.
I want to just tell my agent, like, go file me a claim for this or whatever it may be. I want to learn from the agent and then have the agent act and do things and be able to have it check all of my stuff and do things on external services. But it's my agent. But that means that Amazon now has to, like, maybe it's just an
MCP tool.
Yeah.
It's just an API interface, and like you never get to see their website. Doesn't look amazing though.
Yeah.
I gotta say,
it's okay if that happens, but they don't want to do that. You know, maybe Amazon's a bad example because they're going to throw billions of dollars at the gateway so that they're the number one provider or agent or tool, whatever it may be.
Well, you imagine you open up your phone, you're going to have like the top 5 apps on your phone, whatever that is, right?
Yeah.
For a lot of us, it's some kind of communication app. And, for others, it might be, something to either buy things or potentially like in OpenAI's world, you would just only have ChatGPT and you just do everything, right?
Exactly.
They would like that, right? And I think I can see value from myself in having that life where I just open up my phone and I only have one thing I have to think about. But there's also a trust issue in terms of wanting to have a little bit more control over my experience.
Well, that, and now all of a sudden I have to trust that the prompts that I'm putting in and everything that's going into that context window is A, being executed properly, and B, like, what if some of that stuff that I want or that I put in the context window is sensitive? How do we know that that's not just like now floating around the internet and we've got data brokers on my context windows?
I mean, you probably will.
Which is scary, right? So,
I mean, the EULAs on these things are probably, I don't read them all.
Right? Like, nobody, let's be honest.
Nobody reads them. The longer you make them, the less they'll read them. The longer you make them, the more you're trying to hide in them. Like, it's just, that's an interesting thought process though. Cause even we we offer sort of differentiating software and services. But ultimately, the people who are consuming would just like to have a relatively simple API interface where they get the thing they want, right?
Yeah.
And how do we differentiate in that world? I think that having reliability and consistency, because that's like the definition of a tool to some extent, right? It's hard to make a tool. Maybe it doesn't seem like it differentiates, but in some ways it kind of does. Like if you have a tool that you could always rely on, you're always going to use it.
Yeah.
So I don't know, like it's not as sexy sounding because like an agent seems like it's smarter and can do more. But ultimately, if you have a tool, if you do something really well and you can expose it in a way that's very consistent and reliable, that has value.
Yeah. Well, then the thing is like, are the agents going to be able to place a value on that and go back to it more and more, which maybe they are. I'm not arguing they aren't.
Yeah.
It was a little bit of a trip when I went to San Francisco, and I told these folks who were creating a MCP like glossary or MCP registry is what it was.
Yeah.
I was saying, hey, you guys should have user reviews of the different MCP servers. And they were like, we're going to have agents reviewing the MCP servers and saying how useful the documentation is from the agent angle. And I was like, you're kind of cosmic here on this agent reviewing the agent thing, but I could see it. And then you're like, well, then I'm going to have my agent or my tool market to the agents. And I start going down that road and I'm like, this is fucking crazy.
Yeah. It's not even my head hurts. It just like gets in a place where I lose track of where I am in the universe. Like it's just, how can you even comprehend it? So, you actually brought something up about privacy though, which is really interesting in some ways, because I think a thing that people forget about when they think about scale is security and privacy. Like a lot of the clients that we talk with, it's, again, you start with your laptop, you make some cool little graph rag thing on your laptop and it works great for all your stuff. And you're like, now I want to roll it out to my whole team. And then they're like, yeah, but I don't want you seeing my stuff. And then it gets stuck. And I think that that's a place where people have been stuck. And that's another area where we try to focus on, okay, how do we create an interface at every layer of infrastructure that ensures that you can have sort of lineage, governance, and authorization, not just for source data, but also for the derivatives. And then ultimately, if you're performing some kind of a RAG search, are the vectors labeled so that it knows who you're supposed to be and all of these other pieces. Like those are things that there's lots of different solutions for that are disparate from each other, but they're focused on one area or another. We're trying to kind of we're at the ground layer, let's say. And if we can enforce it all the way down so that individuals don't get access to other data, regardless of how it came in, then we've gotten to a place where now you can scale this thing that you built, right? And have some level of security. Like everybody's like, people like to talk to me about security, and I hate talking about security. I'll be honest. Like that's like the security, like here's the thing. Like if security is easy to implement, then more people do it. And so the requirements may be very difficult, but if you can, this is why I like to focus on the foundational layer and make sure that you don't have some other way in. Because if you implement security at a policy layer up here, but there's another way in to where the data is, then you haven't actually solved the problem. You only solve the problem for everyone who's going up here, right? And so that's why, like, I think that scale isn't just like, am I making, or, the productionizing applications isn't just, can I make sure it operates if there's failure? Can it operate if it gets bigger and bigger with more users? Can it operate when there's more user communities where I can ensure that they're all safe, right? That's like a hard thing to do.
It's like when Germany invaded France in World War II, and France was like, we got you. We're never letting you come an inch into our territory ever again. And they build all these barricades. And then Germany's like, well, I guess we could just go through Belgium.
Yeah. I mean, wow. Okay. Down the war path.